So in my latest plan for world domination, what we're doing is a project in the backyard to put up fairy lights on my pergola and maybe put a 3D printer in my shed so I can do some resin printing without stinking out the whole house. Now, we've already talked about the basic ideas of the sort of things you need to be thinking about, and here we're going to actually do the installation. Now, don't get too tied up on specifics. All of this stuff is really an example of how you go from A to B. Your A and your B may be very different, but how you go there tends to be the same. So of course, obviously, the first thing we've got to do is stick these somewhere where they won't blow off in the wind or get damaged by anything, and to do that, it needs some kind of support or clips. Now often what you see is they're fixed to a roof, but they're not just rested on the roof. There's a framework underneath it holding them firmly, and I'm going to do exactly the same thing. But because I'm fitting mine to a flat roof, of course, what I need is some kind of cradle. And to make my cradle, I've got myself some steel. This bit of angle iron, which is 30 by 30, bit of flat bar 30 by 4 millimeters, and a bit of square tube 20 by 20. And I've got a simple design for a frame that I'm going to use. The next thing we need to do, cut some steel. Right, now we've finished the cutting. What we need to do now is a couple of jobs while it's still like this, because it's so much easier. This is going to be a foot, and a foot needs a couple of holes in it so we can bolt it to the roof. So we need to drill a couple of holes in the feet. And of course this bluey stuff is mill scale, so we need to use a flap sander grinder to get the mill scale off so it's ready to weld. And of course we have the flat bar, which needs a couple of holes in it as well, so we can clip the actual solar panel to the flat bar. Right, that's everything cut, machined and cleaned, ready so we can weld. So let's get the welder out. Right, now I've got 4 of these and 4 of these. I'm going to paint it with Hammerite. I'm going to use Hammerite because it's one coat and it's sitting in my garden. So all I've got to do now, get them painted. Okay, so I've got my sleds, brackets, supports, whatever you want to call them, right there. My solar panels are right there, and I've got to clamber onto that roof right there and fix them in place. So it's all pretty easy. All I've really got to do is bolt the panels in these holes here and then use these holes to fix it to the roof using roofing bolts. These roofing bolts are self-tappers and they come with a little seal on them, so they've got a rubber seal right on there, so you screw them in, this seal against the roof. At the back here, let me get this up, there we go. Yep. This is where those supports bolt in, right there, and they want this at the top so these can dangle down. Okay, that's them up, and you can just see them past the ladder, so clearly they're not that intrusive, which is exactly what I wanted. Now, it honestly doesn't matter much what you use to fix them up there. I made those sleds because I like making things out of steel, but it doesn't really matter. It only matters that you pay attention to your weather conditions. So I live in the south coast of Kent, north coast of Kent actually, and we rarely get high winds. I mean, we get them sometimes, but it's pretty rare, and we rarely get heavy snowfall. So the fixings I've used are really quite appropriate for the conditions I'm in. If you are susceptible to high winds or heavy snowfall, then you do need to think a bit more about how you fix them up. But to be honest, if the nail's big enough, you can fix anything. So the wiring of these things is actually pretty straightforward. I mean, I've got 4 panels at 12 volts each, so I could do a 12 volt system, a 24 volt system, a 48 volt system by wiring them in series and parallel. So if I line up plus minus, plus minus, plus minus, that's series. And if I do all of this with these, so I take the plus, connect it to this minus, take that plus, connect it to that minus, then what I'll get at the end of the chain is 48 volts. And equally, I can gather together all of the pluses and all of the minuses, connect them together, and what I get is a 12 volt system. Now I want a 12 volt system. And for all those people who go, oh no, you want a 48 volt system. No, I don't. I want 12 volts. You want 48 volts. I want 12 volts. Which means I'm going to connect these up in parallel. And that's basically gather everything together. So connect the plus to the plus to the plus to the plus and lead that down. Now, it's not that difficult, actually, because very often, and this one came with a kit with these beautiful little connectors, which is meant to join it up that way, whichever way I want it. And there's only one way they'll actually fit. And so I don't need to worry about them. Now, these connector sheaths are, of course, IP rated, but you don't actually need them. You could, if you wanted to, just chop them off, screw them, wire them together and put some sealant on them. But the connectors make it really convenient. And you can see they only go one way. So if I plug that into there and find exactly the same one from here and plug it into there, there we go, it's joined those up in parallel. And I can do the same thing with the other connector section, which is there and there. And now that's joined up in parallel. And of course what we've got is some pretty cables supplied by the company in the right colours, red and black. And they'll only go in one way, so what I end up with is this with the red and black coming down, and this is the bit that goes to the charge controller. I need to neaten it up, obviously, with a whole load of zip ties. So once we've poked it through the wall, of course, we're ready to attach our charge controllers. That hole there, well, I can weatherproof that again by squeezing in a bit of silicone. Okay, so on those wires, of course, I've got 4, because remember, I'm running a redundant system. I've basically got 2 systems that I'm going to bring together, and as I said, they're 12 volts. Now, I've been saying that I want a 12 volt system, and I want a 12 volt system for reasons, obviously. One of the reasons is because that's the voltage of automotive. Now, if you add recreational vehicles, cars, trucks, lorries, boats all together as automotive, it's an absolutely huge mass market, all running on 12 volts, and of course with a ton of ancillary equipment that will all run on 12 volts. It's because I've been bothered for quite a while about this. One of the things we do for transmission purposes is we transmit electricity around about 10,000 volts and step it down to 120 or 240, actually 230 volts, depending on where you are in the world. Then when it comes into the house, of course, we used to use that. But these days, what we then promptly do is step it down and convert it into DC to run so many things. I mean, your computer, your television, lots of things, your music centre, my 3D printers are all stepped down from the 240 volts to a DC voltage of some description or other, somewhere between 19 and 36 volts. Now, a lot of power has got to be lost in that because inverters tend to be around about 92% efficient or something like that. So we must be losing a lot of power. Why would we want to take a DC input, which is what the solar panels are, convert it into AC, and then reconvert it into DC to run a whole load of equipment? That makes no sense to my mind. And I've always pondered what it would be like if you ran another system where you predominantly used DC, and then at the point at which you're using it, you used an inverter only for those things that need an inverter. And of course, something like automotive, well, you can buy a 2 kilowatt pure sine wave inverter from your local store, Halfords in my case, for about £50. I mean, that's peanuts when it comes to that size of inverter. And as you go down in the size, so a 300 watt inverter is going to cost you about £20 or £30. They're really quite cheap at that level because the electronics are cheap and they're actually pure sine wave and really quite good. And then we only need them for when we need them. Because of course things like lighting, which is a predominant use, if you think lighting, entertainment and electronics, the predominant use that we put electricity to. We have additional stuff sometimes like heating, maybe the Hoover, the washing machine, the fridge, but a huge use of them is in DC form. So how would it be if we didn't bother with AC and didn't bother with an inverter and just run it on DC? That shed, you might have noticed, is a bit more luxurious than a shed. It's actually an outdoor workroom. I built it about 10 years ago, and it's incredibly sturdy, which is why I can put solar cells on the roof and stand on it and jump up and down. Inside it, it's actually got its own distributed electrical system, and it has its own lighting system. And it occurred to me that instead of mucking around with inverters, how about we just fed it straight in, and we used that shed as a DC 12-volt voltage supply. When it comes out of the wall at 12 volts and we would need an AC supply, so for something like, I don't know, one of the printers is AC, then use a cheap inverter at that point. Again, what we're looking at is redundant systems, because if we're only using an inverter at the point at which we need it, then if it goes, we don't lose everything. Now, of course, we do our 240, 120 volts to DC as a legacy. This is what we've used, and so a lot of equipment has been produced in order to use the supply that we've got in country. But going for the 12 volts automotive means there's also an awful lot of 12 volt equipment out there. And if we all did it and there was a sufficient market, of course, manufacturers would make it with the inverter, in inverted commas, inside the actual product, because an awful lot of products don't need inverters. I mean, sure, if we're going to do 12 volts, you might need a DC to DC converter, but that's not going to be very much electronics in order to do that, and I'm quite capable and happy to do that in certain circumstances, and it would be like a power brick. Just like that. But instead of being 240, it would be DC, whatever, 12 volts to DC out, whatever I needed. So we're already used to that idea with these things that you find on every single laptop. So I want to consider that as an idea, and I want to think a bit about that. Now, I've got the batteries, obviously, but I don't have the battery connectors. So what I'm currently doing is waiting for those to arrive before we install the batteries. So we've installed the solar panels. The solar controller, of which I've got two, are a piece of cake. There's just the little connections here and here that you connect in. The batteries are obviously going to connect those in parallel, and parallel means plus, 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 minus, 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 gathered together, instead of series, which is plus, minus, plus, minus. So we're going to connect them in parallel to run our system, or be the batteries for our system. And the big question is, do I feed that straight into the distribution board, which is in that shed, and use 12 volts at the point where I actually want to use it, and then get little inverters or DC to DC buck converters if the piece of equipment that I want to plug into my 12 volt supply needs it? Now, another reason we use high voltage like that, of course, is because of voltage drop over distance. But that shed, I mean, we're talking about 3 foot of travel. Voltage drop is not going to be an issue in a particular setup like that. Given that inverters waste about 8%, then that's quite an improvement in the system. Now, as I said, this has bothered me for a while, and I haven't done anything about it because it's my house. But now I've put the solar in the shed, it's something I can experiment with and see whether it's doable and if it is actually more of a pain than not. So, while we wait for the cable connectors, that's what we're going to be working on. I hope you enjoyed the video. I hope me installing the panels was of help to you. Thank you very much for watching, and please do remember to like and subscribe.